Hello, my name is Omar Alvarez. I'm a student of the University of La Salle. Today I'm going to talk about the article entitled Thermical Conductivity of Aggregate Glass Resin Concrete Rubberized Coat by the civil engineer Iqbal. The objective is to examine the variability of the incorporation of this recycled aggregate of concrete and their power in order to create a hybrid. This study also aims to investigate the thermal conductivity of say hybrids for its applicability and to be used as an usually material. We are going to have materials such as natural coarse aggregates, crushed aggregates of previously tested concrete mixtures, fine aggregates of natural silicate sand with gradation. We also have the tire power, and finally we will have cement used in all mixtures, that is cement ordinary Portland type 1. We also have to know the property of coarse aggregates such as the specific gravity, absorption, and the hardness reflects in table number 1. The mixtures to be used are going to be four. The first to make a conventional concrete constituted by cement, water, coarse aggregates, and fine aggregates as seen in the diagram. The second mixture is going to replace the coarse aggregates by 5 to 12% of coarse aggregates. In the third one, we will replace the fine aggregates with 10 to 12% of type power. And finally, we will have the combination of all these elements in a single mixture in which the coarse aggregates will be substituted in 5 to 12% of coarse aggregates and fine aggregates are going to be replaced by 10% by the type power. In the table we see results of the compression test with their different characteristics mentioned about the using for pretend mixture in the test. As a result, we get a graph of thermal conductivity in which we say how our hybrid has a thermal conductivity lower than that of concrete with natural coarse aggregates, also less than the with coarse aggregates, given that it contains a 10% of type power compared to two others. We have that the mixture of the hybrid exhibit a lower density compared to conventional mixture. Also, the compression test tell us that 25% of RCA can be replaced without significant change in the resistance of compression. It was also found that the percent of reduction of the resistance to a hybrid with respect to conventional concrete can be 19% with a 10% substitution of that type power. We also have the rubber particles can attract the air since it has the tendency to repel the water. This can cause the reduction in the thermal conductivity with the increase of percent of rubber. As a conclusion, it was found that while RCA generally reduced the compressibility strength of the concrete due to increased water absorption of the aggregate and the weak residual mortar layer, it is possible to reduce RCA with a better thermal inertial property due to its lower thermal conductivity of the conventional concrete. The use of 10% of Ra and 12% RCA to produce a hybrid can be improve the thermal conductivity on RCA mix of the same RCA percent of 12%. The hybrid contains 10% of rubber and 10% on RCA, retain 32% reduction in the thermal conductivity over the reference concrete mix and Na. This improvement in the thermal conductivity of hybrid can be find a combined application as an usually material and help in its conservation of an environmental. It will be advised that in the applications of hybrid for structured concrete, strength should be performance to verify the proportion to accept ingredients and the requirement to produce concrete of the required strength.